Hey, what's going on guys? It's Bell here. I record stuff on YouTube, share description for all my information. I do all LeetCode problems. Make sure you subscribe to the channel, give me a big thumbs up to support it, and this is called minimum genetic mutation. A gene string can be represented by an 8-character long string with choices from A, C, G, T. Suppose we need to investigate about a mutation. Mutation from start to end, where one mutation is defined as one single character change in the gene string. For example, we got this initial gene right here. After one mutation, we get this result. Also, there is a given gene bank which records all the valid gene mutations. A gene must be in the bank to make it a valid gene string. Now, given three things: start, end, bank. Your task is to determine what is the minimum number of mutations needed to mutate from start to end. If there is no such mutation, return -1. Note: starting point is assumed to be valid, so it might not be included in the bank. If multiple mutations are needed, all mutations during in the sequence must be valid. You may assume start and end string is not the same. Well, there is no need to check whether start is equal to end and return, for example, 0 steps required. Let's look at those examples real quick. Here we got initial gene right here, start. Here we change T to A, the letter, and check whether a mutation is valid or not based on those records from the bank. Here we got only one record. Mutation is valid, return 1 because mutation is equal to and the final result. Here we got this string right here, this initial gene, change T, for example, to A. We got this mutation right here. Again, check whether there is the same record in the bank. There is the same record, so we gone mutating the gene, that mutation. We change C to A right here. For example, we got this mutation after that. You see, again we check whether mutation is valid or not. It is. Check whether that mutation is equal to the end result. Yes, it's equal to the end result. Return to 2 steps required. We change 2 letters. Well, we can do the breadth first search using Q data structure. Q means first in, first out, FIFO. We add elements to the end of the queue, and then we can remove the elements from the start of the queue, from the head of the queue. That's how that works. Go for it. First, we create a char array. It's called choices. Choices A, then C, G, and T. You could notice from the description of this problem right here, choices. Next, create 2 sets. The first one, the type string, set bank set, new hash set, the type string. The second one is called scene, new hash set, the type string. The first one, in order to check whether the current mutation is valid or not. The second one, in order to know whether we already seen the mutation or not. Here we create the for loop. We're gonna loop through those records in the bank. String b bank. At each iteration we add the current record to the set, bank set. We create the queue data structure, string queue new linked list string. Here we say the queue dot add initial gene and mark this initial gene like mutation as already seen. So scene dot add start. Instead of add we can use offer. Offer method. Next, the number of steps required. Create level is equal to 0. Create the while loop. At the end we're gonna return -1 in the case when there is no such mutation. Right here you see here first we get the size of the queue, dot size. We gonna do that while the queue is not empty. Here create another while loop. While the size of the queue is greater than 0. If it's so, then first we decrement the size by 1 and go here, right? First we decrement the size by 1 and then we go here. If it's not, then we just decrement size by 1 and don't go here. We just ignore that. Here we say string the current new, not new, just queue dot poll. We remove the mutation from the head of the queue. We check whether that mutation is equal to the end result, the end current dot equals equals, and if it does, then we return the number of steps required, the number of mutations, return level. Otherwise, we can create an array, the type char right here, current array, and here say current array is equal to current dot to char array. We convert the current mutation to a new created character array right here. New created, I mean, yeah, right here, and create the for loop int I is equal to 0, I is less than the current array dot length I plus plus. First we should know the alt character at the position of the array of I. Then try all possible mutations, right? We first change A to A, A to C, A to G, A to T, then go here A to A, A to C, A to G, A to T, go here C to A, C to C, C to G, C to T, again, go on doing that. So in order to try all possible combinations, we first need to save, we need to remember the character, the letter at the position of I, then create a for loop, and we gonna loop through those choices: A, C, G, T, char, C, choices, choices right there. Yeah. So first we change the letter at the position of I, the current position, to C, to the current choice, for example A, right, at the beginning. Create the new string, we pass this character array, and check. We got two cases right here. The first one, I mean two conditions right here, not cases, two conditions. The first condition, in the case when the condition when we haven't seen the mutation yet, and the current mutation is valid, means that bang set dot contains new string. Here we map those map that sequence of characters as a string, create a new string, create a new string representing that sequence of characters. Here, if it's so, we gone mutating that gene, say q dot offer new string, mark as seen dot add new string. Here return initial, after we tried the choices, all possible choices, for example, like C to A, C to C, C to G, C to T, we return initial character. That is, for example, right here at this position, we could have T right at the end. So in order to make it right, we should return initial character, that is C. So current array at the position of I is equal to old character, and at the end of each iteration right here while loop, we increment the number of mutations, number of steps required, level by 1. Yeah, that's it. Let me check real quick. Bank set, scene, bank set, queue, linked list, offer, add, level, current array, size, okay, to char array, level, seems good. Let's run this code. Accept it, let's submit. There we go, success, good. Let's look at this example again real quick. So first we got the number of choices, right? Based on this description, we got two sets, bank set, in order to control those mutations, scene, in order to know whether we seen the current mutation or not. We add those records to bank set, we create a queue, we add the current initial gene to the tail of that queue, to the end of that queue, mark that initial gene, initial combination right here, for example, or looking at this example, this one, as seen, create the level, the number of steps required, the number of mutations required, create the current array. We go here, the queue is not empty, we got, for example, offer, queue offer start, so we could have here, queue offer, this right here, scene, we got this right here as well, right? Scene right here as well. Bank set, we got those records right there, right? So level 0, while size of that queue is equal to 1, right? While size is greater than 0, Yes, it is. We decrement size by 1, we got 0. Current is equal to, we poll, we remove that element from the head of the queue. You know, we got that element right there, you know, current. We check whether this mutation is equal to, and that is, you know, that is this one. It is not. We ignore that. Then current array is equal to, you know, we create a new array, the type character, based on this, you know, based on this current mutation. Then we go here, right? We start from the position of we start at the position of 0. Current array, that is right here, you know, the position of 0 at 0 based in Java, 0 right here. We say alt character in order to remember the character at this position, that is A, you know, A. We try all possible combinations right here. We go, you know, choices, we're gonna look through those choices. That is, you know, first A, we say current array at the position I is equal to A, you know, we just, you know, just say again A, we got A, current array, right? I mean, current array, we got, yeah, we got this current array, yeah, we got this sequence. So A, we got new string, create a new string, this string, we haven't seen this combination. No, we have seen that combination. We have seen we already seen this mutation, so we just ignore that. Try another letter, another choice, that is C right here, right? So at the position of I, that is 0, we got, you know, current array, we got, instead of A, we got C. Do the same, new string, create a new string, we got C right here. Scene contains this mutation. We haven't seen this mutation yet, so we check whether that mutation is valid. That mutation is not valid, we ignore that. We try another choice at the position of, you know, G, we got G right here. After that, you know, we got, here we had C, right? We had C, now we have G. Yeah, so here we got G, and I mean alt, we have A right here, we got G, excuse me, we got G, and we had C before, and before we had A. right there. You see, A, C, then G. Right here we got G. So create a new string. Also check whether we seen that string already or not, that combination, and do the same, you know, after that for loop we return the current, the current, like a alt letter, the position of I, the alt letter, and we um, we go 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 at we go to the next position, that is A right here. Then again try to change the choices, you know, again A to A, A to C, A to G, A to T, then go again here, you know, do the same. And in the case when we haven't seen the mutation yet, and the mutation is valid, for example when we are here at the end of that start, we change T to A. Right here we got this mutation. We can see that we haven't seen that mutation yet, so we go here, we check whether that mutation is valid or not. That mutation is valid, so we go on mutating that mutation, that gene. We add that mutation, the current mutation, to the queue and go on exploring that and mark that mutation as seen. Yeah, and after this loop we increment the level by 1 the number of mutations. Yeah, for example after 1 mutation we got here 1, after 2 mutation we got 2, you know. Yeah, and here in the case when, as I said before, the current mutation is equal to end, we return the number of mutations required, otherwise return -1. That's the whole problem. I mean, that is not super hard to understand. You just need to follow those steps. You can do the breadth first search to solve that problem. Yeah, thank you guys for watching. Leave your comments below. I want to know what you think. Follow me on social medias. Follow me on Instagram, add me on Snapchat. Give me a big thumbs up to support my channel. Again, I do all LeetCode problems, and I'll see you next time. Have a good one. Bye.